This video is about solving one-step equation word problems. All right, so when we're going to write equations to solve word problems, then the thing we're going to have to look for are keywords to help us identify their operations. And by operations, we just mean plus, or adding, subtracting, multiplying, and dividing. Okay, so over here in this chart, I've given you just some typical keywords. Now, this is not a complete list of keywords, and they are not always true. All right, so addition, if you're looking at your word problem and they're using the word sum or total or increase, more than, greater than, then that might be telling you to add. All right, subtraction, if you have difference, decrease, how many more, less than, fewer than, okay, then maybe they're telling you to subtract. Okay, most of the time these words indicate adding and subtracting, but there are a few exceptions. With multiplication, if you see the word product or times, twice would be times 2. Tripled would be times 3, right? Of or per. Okay, these words can often represent multiplication. With division, if you see the word quotient or split evenly, sometimes each or average. Half would mean what? Divided by 2. 1/3 would be meaning divided by 3. So these are just words to look for, maybe to sort of think about if you see them, that those could possibly mean adding, multiplying, subtracting, or dividing. I do want to point out a couple of them to you. One of them is the more than, greater than, and it's really the same for less than and fewer than. So if it's not such a big deal with addition, but it is with subtraction. So if I say I have 12, or if I say Mark has 12 shoes less than me, am I saying 12 minus something, or am I saying something minus 12? All right, if I have 20 shoes and I say Mark has 12 shoes less than I do, right, what I'm saying is 20 minus 12, not 12 minus 20, but the way it's worded, the 12 came first. So with less than and fewer than, what you're going to do is you have to switch the order of however it's worded. All right, so 12 less than 4, if you see something like, let's just write this out to the side, or actually have it up here. If I see 12 less than 4, okay, then I'm not going to write that as 12 minus 4. I'm going to switch those numbers and write 4 minus 12, like that. Okay? Same thing with more than and greater than. It actually switches the order. But because addition is commutative, it's not going to be so important in your equation. All right? But it does, the way it's worded really means you should switch the order. Okay, so let's look at some examples. In a recent presidential election, Ohio had 20 electoral votes. This is 14 votes less than Texas had. How many electoral votes did Texas have? All right, so if I just went back over that and tried to figure out what the keywords were, hopefully you would pick up on the less than part. And this is 14 less than Texas, right? So that definitely less than is telling me to subtract, but remember, right, less than and fewer than, I also have to remember to switch the order on these. Okay, you're going to switch the order. All right, so instead of writing 14 minus something, I'm going to do whatever Texas had minus 14. All right, do I know how many electoral votes Texas had? No. Okay, so the part that I don't know, that's when I'm going to have the variable. Okay, and if you want to define your variable, you can. I'm going to call it T. For me, T is going to be Texas. It's going to stand for the Texas votes. All right, so instead of 14 less than Texas now, I would say, okay, well, not 14 minus Texas, but Texas minus 14. Okay, this is what? What is it referring back to? It's just saying that Ohio had 14 votes less than Texas, right? So how much does Ohio have? They have 20, right? Is sometimes is going to be your sign, your keyword for equals. All right, and then after you get your equation written, you're just going to solve it. Remember, we're cutting it in half, isolating the variables over here, so I need to get rid of the minus 14. I do that by doing the opposite or the inverse operation. So I'm going to add 14, get on both sides. Okay, so these go away. T is equal to 34. And what does that mean? It means Texas had 34 votes. 34 votes. All right, look at number T. 3/4 of the students in Alan's class belong to a social network. There are 15 students in his class that belong to a social network. How many students are in Alan's class? All right, so the question is, how many students are in Alan's class? That's typically going to be your variable is what you're trying to find. So I'm going to use A for students in Alan's class, but you can use whatever variable you want, students in Alan's class. All right, so that's the one I don't know. That's what I'm solving for, right? If I go back and I look for my keywords, it kind of, 3/4 kind of reminds me of maybe like 1/4, all right? But it's not something divided by 4. That's not exactly the thing. So I can also look at the word of, and of is actually another keyword, and it's a little word, but it's kind of important. Of means multiply. So I'm going to rewrite this using multiplication. Sorry. So 3/4 of the students in Alan's class would mean 3/4 times the students in Alan's class. Well, I don't know how many students are in Alan's class. I'm calling that A. So 3/4 times A belong to a social network. And then it tells me in the next sentence there are 15 students that belong to a social network, right? So this must mean it's equal to 15. All right, so now to solve it, I'm going to cut it in half. Isolate my variable by doing the opposite or the inverse. The opposite of multiplying is dividing by 3/4. So over here, I'm dividing by 3/4. Right? When I'm dividing fractions, I need to keep, change, flip. So I'm going to make this into a fraction and then keep it. Change to multiply, flip this to the reciprocal. All right? And then I am going to be cross-reducing. That means when I can simplify before I multiply, I'm going to go ahead and do that. So since 15 and 3 are both divisible by 3, I'm going to go ahead and simplify those. When you're multiplying, it's okay to do that. All right, so this is divisible by 3. It'll go 1 time. This is divisible by 3. It'll go 5 times. So now I just multiply the new numbers. 5 times 4 is 20. 1 times 1 is 1. So this is equal to 20. All right, so A is equal to 20. And what was A? There are 20 students in Alan's class. Okay? All right, look at number 3. Marcus earned $45 for working 6 hours, while Tracy earned $59.50 for working 7 hours. Who earned more per hour? All right, so this one, they're talking about 2 different things. I'm going to actually have to set up 2 different equations. And this is one of those tricky ones where sometimes you may think, oh, well, in your head, you may be thinking, I have to divide in order to solve that. And you would be right. The equation that you're writing, okay, how do you typically figure out how much someone made? You multiply their hours times what they get paid, times their, like, if I earn $10 an hour or something like that. All right, so I'm going to say, the equation I'm going to write is I'm going to say 6 times their wage equals $45. Okay, now how am I going to solve this? Well, I'm going to divide it in half, isolate, do the opposite. I'm going to end up dividing, which is what you need to do. To write the equation, I'm going to start off this way. All right, so if I do 6 into 45, it'll go 7 times. The remainder of 3, add your decimal, bring down your 0. 6 will go into 35 times, right? And so then I'm done. So Marcus's wage was what? $7.50. Okay, this is what Marcus made. Right? I want to do the same thing with Tracy. Now, since I already used W, I'm going to use something different for her. So I'm going to say, I'll just use dollars for her. So she works 7 hours times however many dollars she makes per hour would equal her total wages, $59.50. So I'm going to solve it, cut it in half, isolate my variable, do the opposite by dividing. D is going to equal over here. I'm going to decide. How many times 7 will go into 59? I'll go 8 times would be 56. Subtract and get 3. Bring up your decimal. Bring down your 5. 7 will go into 35. 5 times. And I have the 0 still. 7 will go into 0 times. So Tracy made $8.50 per hour. So the question is, who earned more per hour? And you could say $8.50 is more than $7.50, so Tracy earns more per hour. She earns $1 more per hour. All right, the average growth of human hair is 0.5 inch per month. Which of the following equations can be used to determine how long it takes a human to grow 3 inches of hair? All right, so you're also going to see problems where you just have to pick the equation that you could use to find the answer. Now, the equation that you see here may be different than how you would actually solve the problem, all right, but it has to match what's in the problem. All right, so you may be thinking to yourself, oh, I need to divide 3 by 0.5, and you would be correct, but that is not one of the possible equations over here. So kind of work backwards. If you knew, let's see, the cost is how long it takes a human to grow 3 inches of hair. You know how the rate, and you know how long you want it to be. What you don't know is the time, all right? But normally, if I was trying to figure out how much she could grow, I would say the rate times the time would give me the length of her hair. So in this case, the rate is 0.5 times however long it's supposed to grow, okay, is going to equal 3 inches. All right, now you would be right to solve this. You would do what? Divide it. That, again, that wasn't one of our equations over here. All right, so we want to see which one of these matches what we've done. All right, so here you're multiplying 0.5 times 3. That is not what we said to do, okay, so it's not A. Here you would be, if I was solving this, what would I end up doing? I would subtract, right? 3 minus 0.5, is that what I would need to do? Nope. Okay, here, again, this time I would be subtracting the 3, okay? Again, that's not a subtraction problem. Here I have 0.5m equals 3, all right? So to solve this, I would do what? Divide by 0.5, divide by 0.5. Okay, is that the same thing I would do to solve it here? Yes. The only difference really is that they used m and I used t. All right, so this is the equation that matches the word problem. Again, it may not, some of you are going to think, well, I don't even need to write the equation, I know how to solve it. And you would be correct, all right? You are going to divide, but you got to pick the right equation. All right, so number 5, I'm going to choose a word problem that matches this equation. All right, so now they're giving us the equation, and we have to find the word problem. These can be kind of tricky, all right? So I like to read each word problem and kind of write my own equation and then see if it matches the one I'm given. So that's how I'm going to kind of look at this one. Amy buys a notebook that costs $12.50 and a pen that costs $4.25. How much did Amy spend? Okay, if I want to know what she spent, I need to add these two costs together. So $12.50 plus $4.25, and that would equal what Amy spent. Okay, is that the same as that? Now here I would add these together. Here, to solve it, what am I actually going to end up doing? I'm actually going to subtract the $4.25. Okay, so it can't be A. Now, or B, sorry, says John's book costs $4.25 more than Aaron's. If John's book costs $12.50, how much does Aaron's book cost? Okay, so more than Aaron, that's one of those cases where you switch the order. So instead of saying 4.25 or $4.25 plus Aaron's, okay, I could say A plus $4.25 is equal to John's book. All right, well, what was John's book's? $12.50. All right, so is that the same equation? Well, yeah, actually it is the same equation. Looks like that's going to be my answer, but let's look at the other two also. Allison wants to buy a game but only has $12.50. If she has a coupon for $4.25, how much can she spend on the game? All right, so what does a coupon do for you? Does it make your cost go up or down? So let's say she buys a game and she uses her coupon. That's going to be the game with the cost of the game minus her coupon, $4.25. Does that equal, she only has $12.50. It can only be equal to $12.50 because if it's not, then she may not have enough money. All right, so is that the same as this? It's close, okay, we use G, they use A, but it's subtracting $4.25, not adding $4.25. All right, so it's not C. Anthony earns $4.25 per hour. How many hours did he work if he earned $12.50? Okay, this is similar to number 4. This is a rate, what you're earning. How do you get the actual earnings? You multiply times however long you worked. So per hour, this time, $4.25 per hour means times the hour. We don't know how many hours, so $4.25 times the hours is equal to $12.50. Okay, is that the same as what they gave me? No, here to solve it, I would have to divide by 425. Here to solve it, I'm going to subtract. All right, so it's not D either. My final answer is B for that one. All right, so one-step equation word problems. Just look for these keywords to help you figure out what operation is going on. And then make sure you just follow, after you set up your equation, you're just following the rules for solving. All right, see you soon.